Our new chapter is on conic sections. They're called conic sections because if you look at these cones, the 3D silver parts, depending on the way you slice them, you'll end up with either a circle, an ellipse, a parabola, or a hyperbola. So you can see if you cut it straight horizontally, you'll end up with a circle. If you cut it on a diagonal, you'll have an ellipse. If you slice the side off like that, you'll get a parabola. And if you slice it vertically through the top cone and the bottom cone, then you'll end up with a hyperbola. So most of them are made up of two functions. The circle, ellipse, hyperbola, they're all made up of two different functions. So sometimes you have to put two functions in the graphing calculator in order to see the graph. So let's do that for the first example. Our shapes are either going to be circles or ellipses. So the first thing we do to figure it out is we solve our equation for y. That's what we're going to do first. So I'm going to get rid of the x squared on both sides, and I'll have y squared equals 25 minus x squared. And then I need to square root both sides. So I have y equals, and this is where we get two equations from, plus or minus the square root of 25 minus x squared. Don't try to simplify what's underneath that square root sign, just leave it and write the square root sign around it. So the two equations we're going to graph, into y1, we're going to put positive the square root of 25 minus x squared. So we'll type that in the calculator, making sure the hat goes across everything. And then underneath it, in y2 in the calculator, we're going to put negative the square root of 25 minus x squared. So the only difference between the two equations you're typing in is that the first one's positive and the second one is negative. So when you hit graph, you will see, you might want to hit zoom 5, which is zoom square. It'll make everything look kind of proportional. So when you press graph, you will see something that looks like that and then that. It might not be perfectly connected on the x-axis, and that's okay, but you can tell from the shape that the type of conic section, and to answer our first question, is a circle. Alright, so we've taken care of the first thing we have to do. We need to figure out the center. It's pretty obvious from the graph that the center of the circle is at 0, 0. And now we just need to list the intercepts, the x and y intercepts, if they apply to your problem. So let's look at the x-intercepts right here and right here. So to label those points, you can either scroll over on the calculator or you can look in the table. We would be 5 over 0 up, and then we'd be negative 5 over 0 up. Now we need the y-intercepts. If you look on your calculator, you can trace or you can look at the table. You would notice that you are 0 over and 5 up for that intercept, and then the bottom one is 0 over 5 down. So those 4 points would be the answers to what the intercepts are. If you label them right by your picture, that's fine with me. If you list them underneath, that's fine too. Let's try 1b now. So the first step, solve for y. So let's get rid of the 16x squareds on both sides. So we're left with positive 9y squared equals 144 minus 16x squared. So before we can square root, we have to get rid of the 9 by dividing. So I'm going to divide the entire other side by 9. And I'll have y squared equals, I could try to simplify this, but if you look, we're not going to be able to simplify 16 over 9, so let's just keep the whole thing as that big fraction the way we see it, all like that. So now, to get y by itself, we need to square root both sides. And so that's as simple as it's going to get. I'm going to go ahead and put the plus or minus out front. Plus or minus, so you know what our two equations will be. But into y1, you'll put positive the square root of 144 minus 16x squared over 9. And then into y2, you'll put negative the square root of 144 minus 16x squared all over 9. Now that's the way I write it, but how are you going to type it in the calculator? If you're typing it in, type the square root and then type the top inside parentheses, press the divide button, and then press the 9. Same thing for this one. Underneath the square root sign, type everything that's on the top in parentheses, then press the divide button so a slash will appear, and then put the 9. When you do that and you've typed it in the calculator, you'll see something that looks like that. That'll come from y1, and that comes from y2. So this isn't a circle, this is an ellipse. It's like an oval that's standing up tall. So we can answer the first question. The type of conic section is an ellipse. We need the center. The center is at 0, 0. You can tell that right from the graph. And now we need the intercepts, the x and the y. So I'm going to just label them right on the graph. Right here and right here are x-intercepts. Those are 3 over 0 up and negative 3 over 0 up. And now for the y-intercepts. It's taller than it is wide. So the y-intercepts are 4 up. 0 over 4. And right here, which is 0 over negative 4. So that answers all parts of the question. Next, we're going to graph parabolas and hyperbolas. You already know what parabolas look like. Those are the U-shapes. Hyperbolas are kind of like hyperparabolas, because then there's just 2 parabolas. Eventually, you'll learn how to tell what you're going to get just by looking at the equation initially, but for this, we're either going to have parabola or hyperbola. So it's going to be the same process as the first example. We need to solve it for y so that we know what to put in the calculator. For this one, we need to get rid of the 3 first. So we have y squared equals x over 3. Then we'll square root, and so we get y equals, and here's where we get 2 equations, plus or minus the square root of x over 3. So into the calculator, in y1, we'll put positive the square root of x over 3, and it'll probably look like that when you type it. Into y2, we'll put negative the square root of x over 3, and hit graph. Try pressing zoom 5, the zoom square, it'll make everything look nice. And when you do that, you'll get a sideways parabola that starts there and there. So that's what you'll see on your calculator. The top part's y1, the bottom part is y2. So let's answer our 3 questions. The type of conic section we have, since there's just one U-shape, it's a regular parabola. The verteces is plural. We only have one vertex here, and it is at the origin, 0, 0. And now we have to state the direction that this opens. It opens the way the arrows point. Those arrows are pointing to the right. And we're done with the first one. Now let's do 2b. We will solve for y. First, let's get rid of x squared by minusing. So we have, I'm going to have to move this over a little bit. I'm going to scooch it over. We're going to be left with negative y squared equals 4 minus x squared. All right, so I scooched that over. So before we can square root, we need to get rid of that negative 1. To get rid of negative 1, I'm going to divide by negative 1 on both sides. So it's pretty easy to divide everything on the other side by negative 1. What will happen is the signs are going to switch. 4 divided by negative 1 is negative 4, and negative x squared divided by negative 1 is positive x squared. One more step, we're going to square root both sides, and so then we'll have y equals plus or minus negative 4 plus x squared. So into y1, we'll put positive the square root of negative 4 plus x squared. That should be a plus x squared. And into y2, we'll put negative the square root of negative 4 plus x squared. Don't try to flip the signs underneath the square root sign. The only one you make negatives is just on the outside. So we will hit zoom 5, look at the graph, and this time you'll see something like that, and then that. So since there's two U-shapes, this is a hyperbola. Now we are going to have two vertices. The first one's right here. When we look at the coordinates of that point, it's 2 over 0 up. And then when we look at the other side, it's at negative 2, 0. So that takes care of the vertices. And now we need to say the direction this opens. Since the arrows point both to the right and the left, we could say it opens left and right, or we could just use the word that means left and right, which is the word it opens horizontal. And then we're done. I know you learned the distance and midpoint formula in geometry last year, but let's just refresh. We're going to use this circle here as our guide, and it's going to be really helpful to use the midpoint formula. Let's say we know the endpoints of a circle, the endpoints of a diameter, then the center of the circle will be at the midpoint. Or let's say we want to figure out how long the radius is. Well, if we figure out how long the diameter is from one point to the other, then we can just chop it in half and figure out how long the radius is. Or maybe we already know the midpoint. We could figure out from the midpoint to the edge of a circle, and that distance would give us the radius. So here are the formulas. Copy these down. The midpoint formula gives us the actual point where the middle of a line is. So the formula is the x-coordinate of the midpoint and the y-coordinate of the midpoint are calculated when you average the x's, so you add up the two x points and divide them by 2. And then when you average the y-coordinates, so you add them up and divide by 2. That will give you an xy coordinate, and it'll tell you exactly where the midpoint is. The midpoint is a place. If you want to jot that down, it's a place on the graph. The distance formula, on the other hand, gives you a distance. It tells you how long something is. So if we want to know how long something is, like the diameter or the radius, we use this formula. D equals the square root of, in parentheses, x2 minus x1 squared plus the same thing with the y's, y2 minus y1 squared. So all you need are 2 points. Let's use them. My advice to you when you go to figure out problems like these is to start off by drawing a picture of what you have. Because sometimes you're given 2 endpoints of a diameter, sometimes you're already given the center. You just, I think, need a visual of what's happening. So I'm going to real quick make a graph. I have the point 312, so I'm going to label x1, y1, and 9, 4, that'll be x2 and y2. So let's go to 312. I'm just really quick going to go over like a quick 3 and up really quick 12. I'm barely going to count. I'm just going to kind of estimate that that's where it is. And then the second point, 9, 4, I'm going to go pretty far over and then just a little bit up. So there are the 2 points. There's 9, 4, and there's the 3, 12. So those are the endpoints of the diameter. That means our circle goes through those like that, and we're trying to find the center and the radius. We're trying to figure out what are the coordinates of the dot in the middle, and how long is the radius. So we want to figure out how long is it from the middle to the edge. Well, let's start off by finding the center. The center will be smack dab in the middle of our 2 points. So we'll use the midpoint formula that the coordinate of the x and the y in the middle come from adding up the x's and dividing by 2. So it's going to be 3 plus 9. 3 plus 9 divided by 2. And the other coordinate will come from adding up the y's. 12 plus 4. And dividing by 2. So let's simplify this. We have 3 plus 9 is 12 over 2. 12 plus 4 is 16 over 2, which gives us 6, 8. That means the middle, that dot right there, the green dot, is at 6, 8. Given our other coordinates, that seems pretty reasonable. 6, 8 is the center. Next, let's figure out how long the radius is. So now that we know that middle dot is 6, 8, we technically could just figure out the distance from the midpoint, from the center of the circle to the edge, but let's pretend like maybe we got the center wrong. If you use that and then you find the radius, then your next answer will be wrong. So my advice is go ahead and use the endpoints that they gave you, just to eliminate any error that maybe you end up making. Hopefully you don't, though. So let's figure out how long the diameter is, all the way across from the 312 to 94. So we're going to plug those into the distance formula. So we need to subtract the x's. So this time I'm going to do 9 minus 3 and square it. Then I will add the y's that are subtracted. So I'm going to do 4 minus 12 and square it. And now let's simplify. We're going to get, let's see, 9 minus 3 is 6 squared. And 4 minus 12 is negative 8 squared. So let's square the numbers. 6 squared is 36. When you square negative 8, because you're going to type it in parentheses, you get 64. When you add up 36 and 64, you get the square root of 100, which we know is 10. So that tells us the diameter all the way across the circle is 10. But we want the radius, so we're going to take half of it. So the radius will be 5. Now we're done all the way. Good luck.